So it says, two charged objects repel each other with a force F when they are separated a distance d. The distance between the charges is reduced to a third of d. The new force in terms of F will now be what? Okay, Bontley, when the distances, a third d, is it closer together or further apart? When it goes from d to a third d. Closer. So what do you think will happen to the force? Stronger or weaker?
Stronger.
No? Because the distance is smaller, we think it's stronger. So it's definitely not F. So it's one of those options. Ciao. Now, when they give you two scenarios like this, you can either go make up values. So say D is 10, this charge is 2, this charge is 2, blah, blah, blah. Or you can use symbols. So you will see I use symbols now. So the first scenario is always just the plain, what was it originally? F, we have K, Q1, Q2 over, now this is D, right? And plus, instead of R, it's D squared. Now in our second scenario, we have F, K, Q1, Q2 over a third D squared. Is that correct, the way I've written it? Yes, the whole distance must be squared. So that is the trick here. What is the third squared? A ninth, right? Now, if you type in your calculator, so what we basically have is this over a ninth, D squared. So we have 1 over a ninth. That is the same as what? 9. Take your calculator and then you say 1 divided by 1 over 9. You get 9. Right. So that is the same as a ninth, and then this whole business is the same as that whole business, F. Remember we did this with Newton's gravitational law as well? Yes. Okay, so our answer is D. Okay. Then I want to go to question 9.1. We're just going to do 9.1, not 9.2 today. 9.2. Right. It says two identical metal spheres being Q separated by a distance D are suspended from an insulated rigid wooden bar as shown in the diagram below. So the wooden bar is there. Alright. And they have charges that and that respectively. Now immediately I stop. Do we work in microcoulomb? No, we coulomb. Karabo, how do we go from micro to normal?
Multiply by 10 to the power of.
Alright, think nano 9. Nano 9. Right, so it can't be 9 because nano is 9. Nano 9. And we don't actually go smaller than nano. Alright, now they say charge Q experiences electrostatic force. In which direction will Q move, Simpiwe? To the left or to the right? Why do you say to the left? Do you always whisper like this?
No.
Say it with confidence. You're either right or you're wrong. And if you're wrong, we help you. Okay, so say it with confidence loud. Yes. Can a positive thing give electrons? Again, are they touching? No. So they are just attracted to one another. Because positive and negative attract. Okay, so it will be to the left. They didn't ask why. I'm asking why just as a bonus question. So question 9.1.1, we're going to say to the left. And if you want to say, you're going to say positive and negative attract.
Now, can I ask you now, when you say to the left now, because they attract one another, why do you say like to the left, not like to the right, because they attract one another?
So are we asking where does Q go?
Oh, cute.
All right. They say the spheres are now made to touch and then separated. So what happens when charges touch? What, sorry? The only person you can ask is Dimakatso. Until they are equal. Alright, so they touch until they are equal. Now they ask, were electrons removed from or was it transferred to P? Which one do you say, Botumilu? Did P lose electrons or gain electrons when they touch? Say again? There will be a transfer, but from where to where? Will P lose or will P gain? Let him think. Waar gaan jy? Wanneer sien ek julle? Gaan jy Vrydag kan speel? Ja. Okay. It will be removed from. Now they ask, give a reason. Why? That happens when you listen to other people and you don't think. No, photons. Can protons move?
No, that's what I'm saying. Like, photons can move to the other, to the electrons.
Okay, good. Right, so he says, ma'am, this one has excess protons, they can't move. This one has excess electrons, so it can move. Okay. You could have also said this one is more negative than this one, or it has more electrons than that one, so it will give away. So there's a removed from P, give a reason, and P has more excess electrons than Q. Alright, now they say calculate the distance d between the two spheres if the magnitude of the force experienced is that. And that is now after they have touched. So is this still their charges? No. Alright, so I'm going to do this on a separate page. Alrighty, so we must first calculate, this is now 9.1.3, must first calculate the new charge after they've touched. That is where you add the two original charges together. Yeah.
So you might just do the one from